Hey everybody, it's time to go over that challenging homework assignment that you had last night. And yes, it was challenging. It was on independent and dependent types of probability. So let's go over this, make sure we understand before we go into our lesson today. But you're going to have a greater understanding when it's all said and done, all right? So a shelf holds 3 novels, 2 biographies, and a history book. 2 students choose a book at random. What is the probability that students choose the following? So both novels. So I'm going to simulate this with just letters. I'm going to write N, N, N for 3 novels. I'm going to write BB for 2 biography books and an H for a history book. All right, so right now, what is the chance of me just going in and picking a novel? Or what is the probability? There's 3 novels out of 6 total books. So the first fraction is 3/6. Now, this is a dependent event because the second person is not going to have that novel because the first person picked it. We're assuming, right? So now, how many novels are left? Well, there's 2 left out of how many total books? 5. And that's what dependent probability is. There's 1 less outcome, right? And sometimes there'll be 1 less here too in the numerator. So what do? We multiply those 2 fractions to find out the probability of both happening after each other. All right, and when you multiply, you can cross simplify. So that's going to become a 1 and a 3. This becomes a 3, 3. This becomes a 1 and a 1. So you wind up getting just 1/5, which is the same as 20%. All right, you could have just went right across and got 6/30ths, but that's going to simplify to 1/5 also. All right, so let's do the same thing for this guy. I've got 3 novels, 2 biographies, and a history book. So what's the probability that I'm going to get a history book? Well, that's 1 out of 6, right? Because there's 1 history book. And then a novel. Well, how many novels are there? There's 3. But how many total books are there? There's 5, right? So it's 1/6 times 3/5. And I'm going to cross simplify. 3 goes into 6, 1 and 2 times, and you wind up getting 1/10 overall, which is 10%. Okay, so hopefully that helped. All right, Meg is flipping a coin. Now, when she flips a coin or a penny only has, or a coin only has 2 sides. So this is going to be an independent event. The fractions are going to be the same every single time because you can't take away sides to a penny like you can take a book off a shelf. So let's look at number 5. 2. You're flipping the coin twice. What's the probability you're going to get 2 heads in a row? Well, the chance of getting heads is 1/2, right? 1 out of 2 possibilities. And the chance of getting heads again is also 1/2. And what do you do to figure that out? You multiply the 2. 1 times 1 is 1, and 2 times 2 is 4, and it's that easy. You have a 1/4 chance of flipping 2 heads in a row. And how about the next one, a tail followed by a heads? Well, a tail is just as likely as heads, it's 1/2, and then a head is the same, 1/2 and a 1/2. 1/2 times 1/2 is 1/4. And it's that easy, all right? If it was 3, flips, it would be 3 fractions. If it was 4 flips, it'd be 4 fractions, and so on. All right, here we go. You want to get a puppy. Who wants a puppy? Okay. Number 9, you're picking both black dogs. So imagine, here's the deal. You're going to let's say a dog shelter, and you're getting a dog, and these are all the dogs that they had there. They had 5 black retrievers, 3 brown hounds, and 4 black setters. Well, what's the probability that they're both black? Like, let's say 2 people walked in, and they both picked the black dog. Well, they're not going to pick the black dog and put it back. They're going to take it with them. So this is a dependent event, right? So both black. Well, first of all, people are going to make the mistake at looking at the first thing and saying there's only 5 black dogs. When there's 5 plus 4, there's 9 black dogs. So 9 black dogs out of how many total dogs? 9 out of 12, right? Now, if we take one of those away, how many dogs will there be? Well, if there's 5 and 4, let's just take one away up here. Now how many black dogs are there if somebody takes one? There's 8 now, right? And there's 1 less total dog as well. So the denominator is 11, all right? So this is a dependent event because my second pick is going to be affected by my first one. Now when I multiply, I can cross simplify, but before I do that, let's simplify this guy. 9/12 simplifies to 3/4, and then 8 and 4, this 8 can become a 2 and this 4 can become a 1. So 3 times 2 is 6, and 1 times 11 is 11. That simplifies to 6/11. You might have went right across this way, right, and just got 72 over 132, which is fine too. It just needs to be simplified. All right, let's do the next one. A setter, then a hound. How many setters are there? Well, there's 4 out of 12 setters, right? And then times, there's going to be one last dog because I'm going to pick a setter. But does that affect how many hounds there are? No. So there's 3 hounds, right? So 4 twelfths times 3 11ths. Let's simplify 4 twelfths to 1/3. Now the 3's in the diagonal are going to cancel, and you wind up just getting 1/11th. All right, 1/11th. Now both setters, let's look at this guy. Both setters, well, first of all, we have got 4 setters out of 12 total dogs. Now, if I take one of those away, well, how does that affect my numerator? How many setters are left? There's only 3, right? And how many total dogs are there? There's only 11 now. So I'm going to cross simplify. This is going to become a 1 and a 3. Or sorry, I'm going to simplify up and down here, this fraction. Now I'm going to cross simplify. And I get 1/11th. I get the same probability. Okay? So that's how that one works. All right, are these events independent or dependent? So Sam flips a coin and gets heads. He flips a coin and gets tails. Well, can you ever take away the sides of a coin? Will your second flip ever be affected by your first? No. All right, this will always be 1/2 probability. So this is going to be an independent event. And it's an independent event because your second flip would not be affected by your first. All right, there's always going to be the same number of outcomes. All right, and the last problem here, you're going to select 2 cards, a T followed by an N. So what happens if I don't replace the cards before I draw the second one? So right now, what's the probability of selecting a T? In math is fun. Well, we're trying to brainwash you, first of all. Math is fun. But second, there's 1 T out of how many total letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 T out of 9 letters. And now, what happens if I didn't replace it? This becomes a dependent event because I'm not replacing, right? So I'm crossing it off. It's gone. Now, how many N's are there? Didn't affect that, right? I've got 1 N out of how many total cards now? 1, 2, 3, 4, 5, 6, 7, 8. 1 less because the T is gone. So 1 times 1 is 1. 9 times 8 is 72. I have a 1 in 72 chance of that happening. That is very unlikely, right? So that is the homework, guys. We're going to work on this more today, and you're going to get better at it and feel comfortable, more comfortable going into tonight's homework. Good job. Keep on working hard, and it'll come easier to you every time that you do your best. See you guys.